Good morning, everybody. My name is Paul Storm. I work for a company called Micrographics in Cape Town, South Africa. We are an Autodesk reseller, and this morning I'd like to have a look at Revit and the ability for a panel to see when a circuit is overloaded. So does the breaker see that it is overloaded? And how are these warnings managed, and what can we see about it? So in the first place, with the electrical setup, you have to make sure that your voltages and your distribution systems are set up. Over here I've got a power panel, and this power panel is has a amount of power that it can handle, an amount of circuits that it can handle, and it's got a distribution system. And in this case we've got our power receptacles. I've put a filter onto the receptacles to show me when they are within a circuit. So if you look at that, I'm saying if the circuit number is greater than nothing, then show it up overridden as blue. So at the bottom over here you can see we've got some receptacles. At the top there we've got some receptacles. These show up as blue because they're all connected into a circuit. There's a circuit for this office arrangement on the left. There's a circuit for the office arrangement on the right. And here's our third office, and we'd like to add these into a circuit. And you do that as normal. You might click on one of these items, you might add it into a power system. You could select the panel that you want to hook it up to, and then you can also edit the circuit. You can add to the circuit some other receptacles. So you can say that this and that and all these receptacles, they are connected into one circuit. So they'll be connected up using wires and then ultimately end up on a breaker on a panel board. So there we've got them. Let's finish editing the circuit, and there we can see they turned blue, and the reason they turned blue is because they're now hooked up to a circuit. And that's the methodology over here. Alright, so they would have ended up on this panel board under their own circuit. So that's a typical workflow. And now we can recognize that each one of these power points we use up a certain amount of power, right? So over there we can see some information on the electrical data in the type properties. There we can see the switch voltage, the load classification, and the load as being 180 volt amperes or watts. And each one of them per type, this shows the type, that number 2 shows the type, and there's the symbolism for that. And if we wanted to create a panel schedule, remember you can create a panel schedule. If you look under the view tab, you can create your panel schedules. Under the Analyze tab, there's your panel schedules. I've already done so for this project. So under the schedules, the panel schedules, there you can see the power panel schedule for that distribution box. And now you can see that we've got circuit number 1L1, 1L2, and on the right hand side, that's good. So we've got two circuits that's connected up there. And there's the power rating, and there's the size for the power panel 1, circuit 1L2. Let's just see what this is connected to. I'm expecting there to be 3. This one hasn't been connected to a panel yet, so we'll connect that circuit up to a panel, and then on our power panel we'll see that we've got 3 of these circuits. And the idea with these circuits is that you'll try and balance them. Some of them might have induction, and the result of that is that you would reduce the power correction factor that you require if you balance the power, but that is dependent upon the usage of the building as well in reality. So it's a good first approximation, but it's not the be all and end all. Right, so what happens if you look at the circuit? You can see that circuit number 1L2, the one that we created over here at the bottom. If we click on that element and we go up to the electrical circuits contextual tab, There we can see that is called 1L2, and on the right hand side we'll then see the properties of the circuit. And so where most people go wrong, and this includes me from time to time, is I forget that the rating on the power panel on the breaker is not contained within the power panel, it's actually contained within the circuit. And there's the rating of 20 amperes. So once this circuit pulls more than 20 amps, then the breaker is supposed to trip. Now, what's nice about this is if you start hooking up equipment, I'll simulate this by changing the rating. I'll change the rating to 10 amperes. Then you get an error and or a warning, and it says total connected load for circuit 1L2 is exceeding 80% of the defined rating of 10 amperes. So this is a warning that comes up in real time, and you must pay attention to it. You can export this for future reference, but the program itself doesn't allow you to come and have a look at this later and say, well, which ones did I exceed? All right. So as that comes up, my recommendation to you would be fix it or export it, in which case you can come back to it later and see, was it triggered? Was that warning triggered? So it's back to 20 amperes. A way that you might want to do that at the end of the project, remember you might just be in charge of the project, you don't know what you guys have done. So this 10 amperes for instance, as you change the amperage, let's do this to 30 amp. Have a look at the wire sizes. The wire sizes will update. So there's 20, there's 30. The wire sizes increase to a 6 millimeter. There's a 20. So your breaker sizes also have an influence on your wire sizes. But this 10 amp on 1L1 is already exceeding the 80%. But there's no way for you to see the warning on this panel that I know of. I've had a look on the internet as well to see if there's some way to do that. So maybe at the end of the project, just run through a panel schedule. 20 amps is obviously going to be fine. Change back to 10, change back to 20. All right. Or if it wasn't 20, like it is now, and you don't know whether it was triggered, change the 20 to 30, change it up, and then change it down again. And if 20 amperes wasn't the big enough breaker, then it would inform you as such. All right, so at the end of the project, maybe just go, all right, let me go to all the 20 amps, change it out to 30 amps, change it out to 20 amps. Is there a warning? No. Next one. Change it up to 30, change it back to 20. Is there a warning? No. And so you would do that to all your circuits, a bit laborious, but at least you'll be able to see from a design perspective whether you're exceeding the breaker ratings, and then that will help you to just be sure of your design in terms of your amperage that's flowing through your panel. I hope this will help you in the future, and until next time, enjoy Revit.